So on the back side, again, we want to notice something right away. X minus 3y, x minus 3y. The only thing that's different are these numbers here. So we want to see what happens when we change these into y equals form and graph. So I'm going to take this one first. I've got x minus 3y equals 6. Again, we draw our line to separate the sides. We do the opposite operation, so I subtract x from both sides. So x minus x cancels. I bring down the negative 3y. I have 6 minus x left on the right side. Now to get y by itself, I have to divide everything by negative 3. So on the left, negative 3 divided by negative 3 would divide out. On the right, and in case you need it, I'll put this back up there, but 6 divided by negative 3 would be negative 2. And then remember, this is negative 1 divided by negative 3. Now when I do that, I get a big old long decimal. Remember, we go to math, and then we pick fraction. Enter. And it tells us positive 1/3. Good. So now we're going to go ahead and graph that one. We've got negative 2 as our b value, so this is where we're starting. We have 1/3 as our slope. So we would go down to negative 2 and put a point, and then our slope would be up 1 over 3. Up 1 over 3, up 1 over 3. And then again, I'm going to go ahead and go down 1, left 3. Again, just because I didn't bring a ruler and I'm trying to make sure my lines are straight-ish. So we did the first one. Now we're going to go ahead and do the second equation. So we're going to do it up here. So I still have x minus 3y. This time it equals negative 3. So I'm still going to draw the line. Same thing as this one down here. We're going to subtract x from both sides. This cancels. I still bring down the negative 3y. And that leaves me with negative 3 minus x. And then again, just like this one, I'm going to divide everything by negative 3. So this still divides out, and I get y equals negative 3 over negative 3. Again, 1. And then I also need to do this as negative 1 divided by negative 3, just like last time. So we get that same nasty decimal. So we do math, frac, enter, and we get 1/3. So this should look very familiar. This is our b value, this is our m. But what you should automatically notice is that our m values are the same. So if they're the same, we should have automatically recognized that these were going to be parallel lines. But if we didn't, now let's see what happens when we graph. I would start at 1 here, and then I would go up 1 over 3, up 1 over 3, up 1 over 3. And I could go down 1, left 3. And if you notice, they never intersect. And if I draw them real carefully, you should be able to tell that they're always 1, 2, 3 units apart. 1, 2, 3, 1, 2, 3. So no matter what I do, those lines are parallel. So remember, we said that parallel lines means that there is no solution, because the solution is where they intersect, and these two lines never intersect. Good. So that means no matter what point I would pick, I couldn't plug it in and get both equations to be true. Alright, so let's look at the last special case. This is number 4. Again, the first thing that we have to do is put it in y equals form so that we can actually solve. So again, I'm going to do this one first. So I've got 2x minus y equals 1. Draw the line. Again, we're trying to get y by itself, so we're going to move this. Minus 2x, minus 2x. Cancel this out because it subtracts out. I bring down negative y. And then I have 1 minus 2x. Again, I'm not done because the y isn't by itself. This negative is here. So I have to divide by negative 1. Again, on the left side, those would divide out, leaving y by itself. If you're not sure, you can get your calculator out again. 1 divided by negative 1 is negative 1. And then negative 2 divided by negative 1 is positive 2. So when we write the equation, we would have negative 1 plus 2x, and we would be ready to go ahead and graph. So this is our b, this is our m, so we're going to start at negative 1 on the y-axis because it's our y-intercept. And then we're going to follow our slope, which is 2, so we go up 2, right 1. And then, of course, we can do down 2, left 1 if we want to continue our pattern. Good. So now let's look at the second equation. This is 6x minus 3y equals 3. And I'm going to draw the line again. And then I'm going to subtract my 6x. So 6x minus 6x does subtract out. I've got negative 3y equals 3 minus 6x. Then I've got to divide by the negative 3. So again, this side we know would divide out, leaving me with y equals. And now I've got 3 divided by negative 3, which is negative 1. And then negative 6 divided by negative 3, which is positive 2. So I actually get negative 1 plus 2x. Well, that should look very familiar. These are exactly the same thing. So if I try to graph this equation, I'm going to start at negative 1, which is right here. And then I'm going to go up to over 1, up to over 1, up to over 1. I would end up tracing this same exact line a second time. What these are called are coinciding or overlapping lines, which means that it's two lines that are exactly the same. Exactly. Like they have to be exactly the same. Meaning, really and truthfully, they're sitting directly on top of each other. So every point on the two lines touches. Therefore, this is called infinite solutions. It wouldn't matter which point I picked on this line. If I plugged it into both equations, it's going to work because they are exactly the same line. And again, that means same slope, same y-intercept. Meaning they're all the same exact sign, they're the same numbers, they're the same everything. So those are basically your two special cases, parallel lines, which we did at the top, and then our coinciding or overlapping lines, which we did at the bottom. So that's your notes for today. If you didn't do so already, remember you do need to go back and do number 2, and then that's what you'll need to show me in order to get credit for your notes. Have a great day.